Okay, so we're gonna be using the Maclaurin series to approximate cosine, and since cosine is an alternating series, that means we can use the alternating series error bound. So for cosine of x, the Maclaurin expansion is written as this. So, and so on. But basically, actually it's supposed to be a minus, but what we're gonna do is we're gonna approximate, let's say, the sixth degree, using the sixth degree Taylor-Maclaurin expansion, we're gonna approximate cosine of, let's say, pi over 3. And then if we plug in our numbers, what the error bound says is that the error, which is the absolute value, cosine of pi over 3 minus the Maclaurin series for cosine of pi over 3 is going to be less than the next term. And the next term in this case is this term right here. That's x to the 8 over 8 factorial. And then what we get is, we plug in this into our calculators. Then we get 3.59 times 10 to the negative 5. So that's our upper bound for our error, and we know that the error has to be less than that by the alternating series error bound. And what we can do is we can solve for the Maclaurin series at pi over 3, and we get so this is what we get. And then if we basically, using our approximation, we know that cosine of pi over 3 has to be between this value minus our error and plus our error. So what we get from this is that we know using our approximation, cosine of pi over 3 is between these two values. But we already know that cosine of pi over 3 is just 1/2. So it seems like we got a pretty small margin of error. It's down to like a bunch of decimal places, so that's pretty close.